Good afternoon, ladies and gentlemen. Basically, 1 through 4 are, you have this equation here. You have A over B equals C over D. And you're given a different variable to solve for each time in 1 through 4. So for A, if you just cross multiply this B, you're going to get A is equal to BC over D. Right? So that's, any problems with that one?
Alright. The way I did it, I was right. I just multiplied B on each side.
Yeah, and what you do when you multiply B on both sides, what happens is B's cancel and you're left with...
No, like, you got C over D times D.
Yeah.
D is just the denominator.
Yeah, D's your denominator. So your answer is going to be BC over D. Right? BC over D, right? Any questions on that one? Okay, and what happens is 2, you have A over B equals C over D, and now you're trying to solve for B, which is down here. And what I like to do when I have a situation like this, I like to just turn these fractions upside down. Because to me, it just makes it easier to look at and solve, to me. So I put this as D over C, and now I'm trying to solve for B. So now I cross multiply this A, so B equals AD over C. Right? Is that very hard? Now, it so happens that 3 and 4 are quite similar, only they're solved, like 3 is solving for C and 4 is solving for D, but it's the same type of thing otherwise, right? Now we get to 5 and 6, right? Now, one thing in 5th period I did, I got ready to do, and if you look at 5 you have 7, and I think it's sine 48 degrees, is that right?
Yes.
And then that's over sine 23 degrees, is that it? And so what's one thing you have to, before I press the button, what's one thing you have to really watch out for on this? Make sure you're in degrees. In fact, what happened, I brought this up last period, and Becky noticed that my calculator was in radians. So, no, you're exactly right. Good job. So then you press enter, and you know you have a valid answer. And what I want to do is I want to write down the answer where I can to the not hundredths place, to the thousandths place. So what's that to the thousandths place? 13.314. So this is 13. So 13.314. And so that's going to be your answer. Now, have I told you why I like you to go to the third decimal place?
More accurate.
It's more accurate, but the reason 3 is that according to AP testing standards, they like they use 3 decimal places for a correct answer. So a year and a half in case you want to take an AP test or something like that, you'll know that. And then if you're going to use an answer as a preliminary answer to a further calculation, I even recommend going up to 5 decimal places. Because if this is going to be like a halfway answer to that you have to use later on, the error can really increase greatly.
If it's in a calculator, I just copy the answer.
Yeah, if you just copy the answer, and there are features in the calculator. I'm going to show you one here pretty soon. But yeah, Angel's exactly right. In the calculator, it'll give you that as a preliminary answer that you could copy. Exactly. Okay, now we're to problem 7. And And I saw Will got number 7 right. Did anybody else feel like they got number 7? Okay, so let's go look at number 7. What happens is, and I don't know, Will, maybe you can explain number 7.
Nope.
Okay, Will says no. Okay, what you have is I'm going to just sketch a coordinate plane here, XY coordinate plane. Here's an XY coordinate plane. And here is a superimposed unit circle on that coordinate plane. Okay, kind of an oblong looking circle, but so what we're looking for this angle here, an angle here between 0 and 90 degrees that has a sine value of 0.3. Now how would you find out where that is? Yeah, where would you look? How would you determine where that is?
Turn it to degrees.
Pardon me?
Turn it to degrees.
Turn it into degrees?
Yeah.
Well, your calculator, yeah, to do this, your calculator has to be in degrees, which probably is already from problems 5 and 6, right? But, oh, you say turn this into degrees.
Yeah.
How would you do that? Okay, so Kaylee is saying it here. Let's go ahead. So Kaylee has the text, so she knows how to do it now. Good job, Kaylee. So right here, I'm going to draw a horizontal line here. I'm going to call this y equals 0.3. Okay, what is the significance of this line y equals 0.3 that goes horizontal across the coordinate plane? What's the significance of that?
It intersects twice.
Okay, this line intersects twice. Okay, that's an excellent observation, right? But what is the significance of that?
Is the slope 0?
Okay, because what?
The slope?
The slope is 0, right? That's right. But the thing I'm trying to get to, I'll just say it, is over...
It's at the same angle.
Yeah, so over at the top of the unit circle is the coordinate pair 0, 1, right? And so 3/10 of the way up, and so the sine value is 1. So 3/10 of the way up is that. And so we are interested in finding this angle right here, which they call x.
For this interruption, I need all boys and girls track to the locker rooms. Thank you.
Yeah, Kayla's events got canceled, so that's why she... Anyway, what happens here, we're trying to isolate this, and to isolate x, what do you have to do? Well, to isolate that, is we take the inverse sine of sine x. Okay, and what's the inverse sine of sine x? It's x. And so we have to do the inverse sine on the other side of 0.3. So you go to your calculator and you get inverse sine of 0.3 and get this. So 17.458. Okay, so that's number 7. Everybody understand what's going on there? Now, 8, 9, and 10 require the use of reference angles, or in the understanding of reference angles in different quadrants. So right now in 8, we have the same sort of thing, except we're interested between 90 degrees and 180 degrees. Pardon me? Okay, so Kaylee asked the question here, she's asked the question, she said, you just subtract it from 180. And what it is you have a reference angle right here, and I'm going to call this reference angle alpha, but this reference angle alpha is going to be the same as what we earlier calculated, right? And we're trying to find this thing for problem 8, just like this, right? So yeah, so what we have is x is going to be 180 minus that angle alpha, which is the same as angle x in problem 7. So it's going to be 180 minus 17 point, whatever it is, 458. So this is an instance where this alpha, 17.458, is a reference angle. And so you can just go ahead and put this in your calculator. What do you get for that? 163 point, or 162 point 542, okay. 162.542 degrees, okay? So that's 8. 9. I want you to go ahead and take a stab at 9. You have an idea of 9? I think you do. You know?
This is confusing.
Is it confusing?
Yeah.
Well, it has to do with reference angles. But do you get, Hannah, do you see why we're looking for an angle in standard position that starts here and goes here? So this angle x that was calculated here is going to be the same as this angle over here. Do you see that? Because of symmetry. And Will mentioned this a little bit earlier, right, Will? So it intersects twice. And so this angle, and it's going to be the positive number of this angle, you subtract it from 180, and then you get the standard position.
So the negative 0.7 is going to be on the other side of the circle?
Yeah, so your negative 0.7 is going to be down here. So I'm just going to draw it in here. So we have y equals negative 0.7. And so what we're looking for is this thing right here. Okay, we're looking for this right here. We're looking for this angle. I'm drawing this in black. For problem 9, it's going to be this angle, actually from right here, all the way around. So angle x here, this for problem 9, is this thing right here. This whole thing. So what are you going to have here? And this will be your alpha for this one here, right? And how do you find this angle here?
To find that, can you do the same thing you did for like number 7 and then subtract?
Yeah, let's go ahead and do this. What we have to do is we're going to find this thing right here. We're going to find that angle right here. How do you find this? Go back here. We have inverse sine of negative 0.7, right?
Yeah.
So we get negative 44.427. So negative 44.427. Well, what's this angle here going to be?
Same thing?
Well, it's going to be, okay, what it is, alpha is going to be 44.427. Okay, because what did we learn about reference angles? Reference angles are always positive. And so x is going to be 180 plus alpha, which in this case is going to be 180 degrees plus 44.427 degrees. And that's going to be 224.427 degrees. Okay? And the last one we're looking at is number 10, and what's number 10 going to be?
76. Do you subtract it from, you subtract that number from 360?
Yeah, so you subtract your reference angle from 360.
Oh, the reference angle.
So what is our reference angle?
44.427.
So there's our reference angle right here.
3.
So in this case, x is going to be 360 minus alpha. So it's going to be 360 minus 44.427. So x is going to be equal to
15.573.
degrees, okay? So that's it. We are about out of class time. So we'll just leave it there.